So this is just another video in our series on motion graphs. We are going to go very deep in the topic of velocity versus time graphs. So let's get started. Alright, so the first thing that I want to remind you of on velocity versus time graphs, you have to remember that the slope is equal to the acceleration and the area is equal to the displacement. And if you want to know how that is so, go look at one of my older videos on motion graphs. I went into the reasoning behind that. I'm not going to do that in this video, but let's go down, let's look at some example problems here. So we want to find the velocity on this velocity versus time graph at a couple different times, at 2 seconds, 4 seconds, 6 seconds, and 7 seconds. So let's go over here, let's look at what the velocity would be at 2 seconds. Well, we go 2 seconds up right there, so probably about 1.5 meters per second. You notice our units for velocity are meters per second on this. And then we got our time at 4 seconds, so let's look at 4 seconds right there. That's at 2 meters per second. And then what else was there? 6 seconds. So at 6 seconds, well, we're right here. So that is 0 meters per second. It's on the axis. And then, let me zoom out just a hair. And then we also have 7 seconds, which is right here. So that would be, well, there's no number there, but we could deduce that that would probably be -1, and this is a -2. So right here, we're at -2 meters per second. So that's just basically reading a velocity versus time graph. But there's another question that we have here. Find the acceleration at t equals 0 to 3 seconds, 3 to 5, and 5 to 7. So we need to find the acceleration of these different sections. So let me grab a different color here so we know that we are doing acceleration. So from 0 to 3 seconds, what is the acceleration that's going on right there? Remember, the slope is the acceleration on a velocity versus time graph. So right there, our rise is 2, our run is 3. Well, 2 divided by 3, that gives us obviously 0.67. So for 0 to 3 seconds, our acceleration is 0.67 meters per second squared. That's our units for acceleration. What about time 3 to 5 seconds? Let's go back to our graph here. 3 to 5 seconds is this section right here. Well, it's a flat line, so there's not really any math that you need to do. There's no slope. So from 3 to 5 seconds, that's 0 meters per second squared. No acceleration going on. And then we got 5 to 7, which is from here all the way down to here. So let's see here. So what's going on here? So our rise, it starts off at 2 and it ends at -2. So for this section, our rise is actually -4 because it goes down 4. And then our run, well, it goes from 5 to 7, so that's 2, which gives us, well, -2. So from 5 to 7 seconds, that's -2 meters per second squared. All right, so that's just basically reading a velocity versus time graph and finding the acceleration. Keep in mind that if the slope is going upwards, that's positive. Flat is no acceleration, and if the slope is going downwards, that's a negative acceleration. All right, let's look at this one. What is the displacement? So we're going to find the displacement on this velocity versus time graph. Remember, displacement is the area underneath the line, so from the line to the axis. So we're probably going to want to break this one up into 2 different sections where we got this triangle right here, and then we'll have this rectangle over here. So if we find the area of those 2 shapes, then we have our area underneath the line. Therefore, we have our displacement, which is what the question's asking for. What is the displacement? So let's look at this. We want to be a little careful with this because we notice it doesn't go up by 1s and it doesn't go over by 1s. So let's take this first section, this area right here. Let me make my line just a little bit smaller. All right, so since this is a triangle, the area is equal to 1/2 base times height. And this area 1/2, the base, we notice that it starts at 0, then it goes to 5, 10, 15. So our base is 15. And our height, we notice it goes from 10 to 20. So our height is 20. So the area is equal to 0.5 times 15 times 20, which gives us 150. So that's the area for that little triangle. And then let's find the area for this rectangle here. So the area for a rectangle is length times width. So let's say our length, well, it starts at 15 and it goes to 35. So that's a 5, 10, 15, 20. So our length is 20, and our width, we're going to say that's the height going up here. So that's 0 to 10 to 20. So 20 times 20, we know that's 400, right? 20 times 20 equals 400. So area equals 400. So 150 plus 400 is equal to 550. So to answer the question, what is the displacement? It is 550 meters. All right, so just by finding the area underneath the line, we got our displacement on our velocity versus time graph. Great. So here in this graph, we want to describe the motion that we have. So what is happening here? Well, you notice on our y-axis, we got some kind of funny numbers, 29.4, 19.6, 9.8, negative 9.8, negative 19.6, negative 29.4. And you notice it's a straight line. It's slanted, but there's no curves in it. So anyway, it's got a slope to it. And if you notice, after it hits 0 meters per second, it goes to negative 9.8 meters per second, negative 19.6, negative 29.4. If you watched my How to Solve Free Fall Problems video, you might pick up on something here. You notice that it's actually accelerating. It's accelerating downwards after 3 seconds here. It's accelerating downwards at a rate of negative 9.8 meters per second squared. Every second it gains another negative 9.8 meters per second. So anyway, you notice that on the bottom half, but what's going on in the top half? So it starts off really fast, 29.4. It slows down to 19.6. It slows down to 9.8. So we're going to describe the motion. So it looks like the second half, it's something that's falling. The first half, it was really fast and was slowing down, so it's probably something that was thrown up in the air, and then it comes falling back down is what's happening here. So describe the motion. Most likely, I'm going to say, is an object thrown in the air and falling back down. So that's what's happening there. It's an object that was thrown in the air and it's falling back down. So the next question would be, well, what is the displacement? So once again, we're going to find the area underneath the curve. Let me find a different color here. Let's go green. All right, so we're going to find the area underneath this part right here. And then we're going to find the area underneath this part right here. And notice that stops at 6, so right there. All right, so let's find the area of this top part right here. You notice it's a triangle again, so that's area equals 1/2 base times height. Area equals 1/2. Our base is from 0 to 3, so that means our base is 3. Our height is 29.4. 29.4. So the area here is 0.5 times 3 times 29.4. We get 44.1. So 44.1 meters is our displacement for the top half. Let's find out the displacement for the bottom half. It's going to be the same thing. Area equals 1/2 base times height. So we got 1/2. Our base is from 3 to 6, so that means it's 3. And then the height is negative 29.4. So we got 0.5 times 3 times negative 29.4, which gives us an area of negative 44.1 meters. So for the bottom half, our displacement is negative 44.1. So the question is, what is the displacement? Well, it's 44.1 plus negative 44.1, which gives us a 0 meter displacement. And that makes sense because it's, like I said, it's an object that flew up in the air, fell back down, landed right back where it started. Anyway, thanks for watching. I hope you learned something. If you did learn something and you want to see more videos, make sure to hit that subscribe button. If this was helpful to you, hit that like button and stay tuned for more awesome physics videos.